Hi and welcome to the demo lesson where we will see different transformations you can apply on top of streaming data. So to start, I will start with the transformation I called simple transformation because generally they are very, I would say, easy to understand and also have a very small complexity behind. So the first operation is the filter map example. So here we simply eliminate some rows we don't want to process with this filter expression, and we do some projection. We select only the columns we want to process, and in the end we do the mapping. So in the mapping here I explicitly use the map function to stay the same with the Scala API, but you should know that for PySpark much more convenient and much more efficient way would be to use the map in pandas or map in arrow, because generally this function works on the batches of elements, whereas here we are, even with the map, we clearly operate on a single item, which adds a lot of serialization and deserialization overhead, which is maybe very bad for the performance, but still, just to give you a clear picture and to understand both languages, I'm using the map function. So later I'm mapping this single value to some another value, and that's all. As you can see, it's not very challenging or not very complicated, and I'm using an in-memory RAID micro batch data source. So let's keep it running, and we should see some data multiplied by 2 printed on the screen. Yes, you can see that we have this coming. And that was the first kind of simple transformation. The second simple transformation is for the flat map. So flat map, remember, it's a little bit different than the map because it can create one or multiple elements from a single input. So here I'm creating a multiplication array with multiplication numbers by 2 and by 3, still by using the filter I defined previously. So here, instead of seeing one row for each line, we should see 2 rows. And you can see that I put this input value here, and for each input value we have 2 different rows with 2 different multiplication results. So these two was the simple transformations. Now Apache Spark, because of its micro batch semantic, also has some partition-based transformation. So the first one is for the for each, and the for each is, well, not complicated, not complex, because it initializes a kind of processor on each partition and runs it for each row individually, for each row living in the given partition. So to show you that, I explicitly define this open method where I will print the partition number and the batch number, and I'm also processing some data with a sample print. It's not the key reason here. The reason is that it can be a job that doesn't, that with this kind of operations. So I will just maybe stop here and explain and give you some complete notes just after. So yeah, we have different partitions, we have different batch numbers, as you can see, and you can also see that we are processing the rows. So to complete this demo, I wanted to give you a purpose for the for each writer. So it's typically used when you don't have skills to deep dive into Apache Spark and define your own data sync. Here, with quite high level API, you can use it to define a sync that is not natively implemented in Apache Spark. So for example, I don't know if you are using a Neo4j or any other, I would say, more exotic database, you can implement the connection here. Or if you require some custom operation, even for the natively supported syncs, well, it can be also a place to put it there. The second type of transformations, this time this transformation returns something, so it's not the final part, is the map partition. So still it relies on the aspect of having microbatch processing, which locates a lot of data on a single partition and applies a same processing method on top of it. So here again I'm using the map partitions with RDD, and here instead of returning a list I'm using the yield statement, which is a kind of lazy evaluator, meaning that it can save you some memory pressure because it generates one row at a time. It doesn't materialize the whole results at once. So let me run the code. And you should see right now that generally we achieve the same result as for the filter map because we have the multiplication by 2, but we are doing it by applying the same transformation on multiple rows. So typically here, if you have some JDBC connection, so database connection to open, you can generally do it that way. So open connection. Later in your multiply the numbers you're doing the processing, relying on the information provided by the data from this connection, and later before you do a closed connection or something like that, so that you only keep one connection open for each partition. So that's one of the use cases. The partition-based processing is not the single one. Of course, you can also operate on groups as you operate on groups for batch. So I bet that you already wrote a code for SQL queries to know the number of elements, to do some sums, aggregations. So you can do exactly the same thing for this streaming part. And in Apache Spark structured streaming, the API is very similar to what you can write for the batch part. So we have our group column. For me, it will be even odd or odd label, true or so even or odd. And later I'm doing the count. So I'm counting the number of items for each of the labels. And you will see that this count is accumulative, so it will accumulate with time. You will never have the count which is local to the micro batch, except of course for the first run because we don't have any history. But this is not the topic. So you have 3, 2, and here we should see here 5, 5, 8, 7, and so forth and so on. And behind the scene, it uses stateful operations, but of course here we are only in the introduction to streaming processing, and we will not cover that topic now. And besides this, we also have the combinational transformations that I would say combine different data sets. So here we are doing the join between a static data set, which is a kind of static set of numbers, with our rate microbatch streaming data source, and we are printing the result in the console. That's only one example because you can also do joins between different streaming sources, but since it's also a topic for, it's also a stateful processing behind, I don't want to introduce it at this moment. You can just see that we correctly joining these two different values from the streaming part, so timestamp value, and for the batch part, so key and label. So, and finally, just to give you a glimpse on the stateful processing, I will show you one maybe much more specific example. So it's a kind of grouping transformation, but that involves a state because of the session window. So here we are defining our source, our grouping label, and also the watermark that generally defines, for this case, how late data can be for each micro batch. And later we have our group by statement and session window aggregation. And this session window aggregation will group all labels for a given period. And if there is no new data for 2 seconds, well, it will close the session window and open a new one. So I will just run the code. You will probably see it much more better. At least the difference is not the same as, at least the result will not be the same as for the counts. So yeah, you could see that we advanced the watermark. So it considered that this session window will not receive any data because we were generally in the second number 5. and it closed this session window and emitted the results to the final sync to the console. And it happened also for others, and you can see that typically for this case we are doing a local count for each items. And why so? So remember, session window has duration of 2 seconds, and we advance each microbatch of 3 seconds, meaning that generally each time the microbatch advances, the previous window is closed because of this gap duration. So we can here see that we started with 0, 0, and the gap duration is 2 seconds, so we set the end of the window to 0, 0, 0, 2, and the next data comes at 0, 0, 0, 3, so already after this closing period, and that's why we close the previous session, the previous window, and open a new one. And yeah, that's generally all for the types of transformations. So I know I gave you here the examples for Apache Spark, but you can do almost the same things with Apache Flink, either with literally using the same API. So if you take a look at the map or function, you will also be able to apply them on top of your streaming data, or with a little bit changes, like for example explicit key based processing or something like that, to simulate the partition based functions. That's all for this demo. I hope you have now a better vision on different operations you can do with streaming data. You can see that it's very similar to the batch operations, even though these for the streaming use under the hood some other external components, especially for the stateful processing. But as I said, stateful processing is not the topic of this module, and we will see it in details in the next module. So thanks for watching, and see you in the next lesson.